Here in this video, we are solving a problem that appeared in NEET 2025. The problem is like this. Two gases A and B are filled at the same pressure in a separate cylinders with a movable pistons of radius RA and RB. So the first thing that we need to notice here is it is given that the radius of the first one and the radius of the second one are going to be different. They are having two different radii, but they are under the same pressure. That means pressure P1 equal to P2, right? On supplying equal amount of the heat to both the systems. So he is further putting a condition for you that heat supplied to the first one equal to the heat supplied to the second one. Under the same constant pressure, the pistons of the gas is displaced by certain distance given for you. If the change in the internal energy is same, another condition is given for you. Change in the internal energy of the first case equal to change in the internal energy of the second case. Then what's the ratio of their radii is given for you. So we can use the first law of thermodynamics, which says you that the heat energy supplied to the system is used in two parts, which change in internal energy and do some external work. So here dq as for the problem is not different because same heat energy is supplied. du is not different because same internal energy is. Therefore what we can say, dw is constant in both the cases. So work done can be written like pdv, who is also constant. Here further it is given that the pressure is constant. So what we can say, as pressure is constant, change in the volume of both the systems is constant. Volume change is area into change in the length. That is constant. So you can write A1 delta L1 equal to A2 delta L2. Cylinders having a radius means they are having a circular cross section. So pi R1 square delta L1 equal to pi R2 square delta L2. Pi's and pi's can be cancelled. So R1 by R2 whole square equal to change in the length of the second case by change in the length of the first case. That implies we take the square root on both the sides. R1 by R2 equal to delta L2 by delta L1 under the square root or whole power of half. This is what we have to find out. Change in the second length is 9 and the first length is 16. So 9 by 16 under square root whole power half. That is 3 by 4. So the ratio of the radii of both of them shall be equal to 3 by 4, who is the answer for the problem. That's it. So this entire problem is based on one basic concept, that first law of thermodynamics, that heat energy is supplied to the system equal to the sum of change in internal energy and the external work done by it. Not only that, there are so many things given for you to simplify the problem, that the pressures are same, heat energy supplied is same, change in internal energy is same. That implies problem simply boiled down to a very simple a kid's equation, right? This is how we have to get the answer for the problem. Thank you for watching.